Hello, I welcome you all to this wonderful question looking at electricity. Specifically, it's falling under current and potential difference. How to calculate this? Before we look at this question, we've got this wonderful question that is here. What is the difference between EMF and PD? Maybe there are people that don't know what EMF means or stand for. This is electromotive force, and the PD, this is the potential difference. So they are telling us to say, what is the difference between electromotive force and the what? And the potential difference. So to answer that particular question, I'm going to say solutions. I'm just going to give you certain parts that you have to understand. So this is question number 1. So whenever we are talking about electromotive force, you say that is the what? Is the energy. This is the energy that is supplied. So the energy what? Energy supplied to each coulomb of charge. Energy supplied to each coulomb of charge. To each coulomb of charge. This is what you have to understand. Energy supplied to each coulomb of what? Of charge within it. So this is coulomb of charge within it. We say within it. Wow! When we talk about the PD, which is the potential difference, what we are talking about is the energy. So while PD is the what? Is, so we say PD is energy that is converted. So this one is the energy that is what? Converted. You say is the energy that is converted per unit charge. Per what? Per unit charge. You say per unit charge that is passing through a component. So this one is passing what? Passing through a component. Passing through a what? A component. This is a difference that gets to exist between the two. So this potential difference that we are talking about, some of you don't understand what potential difference is. So when energy is carried by charge in the form of charge, you discover that a battery is consumed or a cell is consumed in electric components like a bulb. We get to talk of a lamp, maybe a heater of the circuit. A good example that we can look at is when the charges flow through a bulb in a circuit, their energy is converted to heat and light energy, where we are able to see light, see if it's a phone, it is charging. So that energy that is being consumed is what we get to call potential difference. You discover that some units get to move, isn't it? So that is what we are calling potential difference. So when you are charging your phone, you are using some energy. Energy is being consumed. So that is what we call the what? That is what we call the potential difference. We now move on to these other wonderful questions. We move now to question number 2. Question number 2A. So the question is saying a charge of 42 coulomb flows through a bulb, flows through a bulb for 3 minutes. So whenever we are talking about charge circuit, here we need to make sure that we change the 3 minutes to seconds. So that is 3, you know that we multiply 3 times 1 minute is 60 seconds. So 3 times 60, that is 180. So that is 180 seconds. We change in advance. We need to make sure that time is in seconds. Then 240 joules of energy are consumed. So 240 joules of energy are what? Are consumed. The first question is saying, how much current flows through the bulb? They want us to calculate the current that flows through the bulb, you need to understand that the formula that is there is that current is equal to charge over time. This is a particular formula that we know, isn't it? This formula, we know it. So this is a formula that we know. So for us to answer this particular question, how are we going to do it? How are we going to answer this particular question? So sorry, it is not like this. The actual formula is like this, not like this. It is charge is equal to a current times time. This is how the formula is. So if we make current the subject to the formula, we say we divide by t, even here we divide by t. So meaning that we are going to, this will be cancelled. We are going to form a current which is equal to what? Charge over time. This is the formula, not the way I'd written it at first. We need to make sure that the formula is charge is equal to current times time. Then we make a current the subject of the formula. So we need to make current the subject of the formula where we divide by tt. So we are going to have charge over what? Over time. Then from here we substitute. We know charge. Charge is what? What is charge? Charge is 42. So I say 42 like this, 42 coulombs over time. Time is what? 180. I say 180 seconds. So you get your calculator and punch that. What is your answer? 42 divide 180. What answer are you going to have there? You are going to have 0.2. The 3's are just going 3. So we can just put in a 3, then we put amps. So meaning this is the current. Just like that, we are done. So this is the answer. We now move on to the next question here that is telling us to say, calculate the potential difference across the bulb. How then can we calculate the potential difference across the bulb? We know and understand that the formula for potential difference, so we move to B. The formula for potential difference, we understand that, okay, the formula for that is what? Potential difference is equal to energy over what? Over charge. This is a particular formula we get to use. Energy over what? Charge. Where we say, okay, energy, they are in the question here, they are telling us to say what? 210 joules of energy are consumed. So energy there, it is what? 240. Charge, that is 42. The charge, that is 42. So energy, we put a 210 there, 210 joules over what? Charge, which is 42. When we divide there, what answer are we getting? Get our calculator. We say 210 divide 42. What is the answer? The answer is 5. So I just say 5 what? 5 volts, or I can say 5 what? Joules per coulomb, because these are 42 coulomb. So it is just one and the same. This is how you answer this particular question. Hope you've seen all these procedures that I was doing. So this is what we need to do. This is something we need to get and understand. So this is where we are going to end from. I guess you've learned one or two things. This is a public lesson. Those of you that are interested in starting your tuitions with me, you can WhatsApp me on my number. So this is my WhatsApp number. So drop a text on WhatsApp. I'm going to help you clear your exams. So this is my WhatsApp number. Don't forget, I also have a Facebook page. You can also follow me on Facebook. This is my name. So I want people to follow me on Facebook so that you get to see each update that I get to post. So this is the official Facebook page name. So if you've not followed me on Facebook, you can do it now.